In today's lesson, we are going to evaluate inverse trig functions. So starting out, kind of just like an introduction and review of what an inverse function means. So let's just start with sine of x. So we've been graphing these functions, so I'm just going to sketch the sine graph. And now let's think about these points. So we've got the point 0, 0, pi over 2, 1, pi 0, 3 pi over 2 goes to negative 1, and then 2 pi back to 0. So now let's think about the inverse of sine. Well, inverse functions switch x and y. So first I'm going to rewrite all of these points, but just switching x and y. So still have 0, 0, but then I've got 1 pi over 2, 0 pi, negative 1, 3 pi over 2, 0, 2 pi. So what happens if we graph those? 0, 0, 1, this would be pi over 2, back to pi. So if you try to graph this, what's wrong with it is it's not a function. It fails the vertical line test. It's going to cross the graph more than once when you draw a vertical line. So the idea is, can we still, so we'll just have to restrict the range of this function so that it is a function. So if you look at this graph, think about where it fails that vertical line test. So I start going up here, and the second I make this curve, it fails right there. So what we want is a section of the graph where it doesn't fail. So from here to here, it doesn't fail. But what we're going to do is actually shift that down. So it's still, we've got the 0, 0, and then the 1 pi over 2, and then the negative 1, negative pi over 2. So this right here, we're just going to draw that and then stop. That's the graph of inverse sine. So quickly going to do the same thing with cosine. If we just sketch out regular cosine function, which we've done a bunch, it kind of does something like this. And those points, 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi back to 1. So now the idea of, let's switch the x and y in graph. Okay, so switching the x and y, and then if we graph, I've got the point 1, 0, 0 pi over 2, negative 1 pi, then it goes back, back. So once again, just like sine, is it's going to not be a function. It's going to break that vertical line test. So for this one, we're just going to cut off this part of the graph. That does not look great, but we're going to get the idea. Whoop. Okay, so there I fixed it so it looks a little bit better. Okay, so now to kind of summarize, here I have inverse sine, and here was what the graph looked like. So the domain is from negative 1 to 1, and now the range is negative pi over 2 to pi over 2. So we're evaluating inverse sine functions. If we use the unit circle, we were only going to be using the first quadrant. So that's to the pi over 2. And then negative pi over 2 goes this way. So this is negative pi over 2. So then instead of 11 pi over 6, we're going to call that negative pi over 6. negative pi over 4 and negative pi over 3. So when we're using inverse sine, this is the part of the unit circle we will use. So over here, I'm just going to sketch this and erase this so we can talk about cosine. Okay, so inverse cosine, similar, but just slightly different. The domain is still from -1 to 1, and then the range is from 0 to pi. So 0 to pi, when we're dealing with inverse cosine, we'll be using quadrants 1 and 2. So kind of makes yourself a little note. Inverse cosine, we'll be using those two quadrants. Okay, so now for inverse tan. So if you think about regular tan, you have all of these vertical asymptotes, and you've got this graph. So if you start switching to inverse tan, what you're going to have is now we're going to have horizontal asymptotes. And we can't have the tan function over and over again. That's not a very good sketch, but because that would not be a function. So what we're going to have is just one like this that has the range from negative pi over 2 to pi over 2. So domain of tangent is all real numbers, but the range, similar to inverse sine, is negative pi over 2 to pi over 2. So for tangent, this circle will look the same, only using quadrants 1 and 4. So now we're going to evaluate these trig functions. So I've got inverse sine of 1/2. So inverse functions, this is now asking you which radian corresponds to when sine is 1/2. Well, sine is 1/2, positive 1/2 here and here. But this one is not in the range of inverse sine. And then down here, this is where it goes negative. So the answer is pi over 6. Okay, the next one, it's inverse sine, but the inverse trig functions are also written this way. So we're going to call this arc sine. Arc sine and inverse sine mean the same thing. So arc sine of negative square root of 2 over 2. So which radian has sine at negative square root of 2 over 2? So we've got this one and this one. This one's not in the range. And then this one, remember, with sine and tangent, instead of these radians, we're going to call this negative pi over 6, negative pi over 4, and negative pi over 3. So negative pi over 4 is the answer. All right, next one, inverse sine of 1, or negative 1. So negative 1, that is at negative pi over 2. All right, let's switch over to inverse cosine. Inverse cosine of negative square root of 2 over 2. Okay, so here we have, so cosine switches to the x. We've got these. Well, this one is not in the domain, but this one is. Cosine are these first two quadrants. So that is at 3 pi over 4. Okay, similar to this arc sine is arc cosine. So that means inverse sine of negative square root of 3 over 2. Negative square root of 3 over 2 is right here, so that is 5 pi over 6. Okay, inverse sine of negative 1/2. Negative 1/2 is right here, that's 2 pi over 3. Okay, let's do a couple tangent ones. So tangent, inverse tan of negative 1. Okay, so let's see, tangent, we only want to do these two quadrants here. And it would be positive up here, and it's going to be negative down here. And then you always get 1 or negative 1 at the pi over 4s, because those are anything divided by itself. So if you want to make yourself a little note, so at the pi over 4, so if we're dealing with just like tangent of x, this was always 1. This one, it would be the square root of 3 over 3, and then this is your square root of 3. Okay, so back to this. So we've got negative 1 would be here, which is at negative pi over 4. And then the last one, inverse tan or arctan, square root of 3. So that's what I just added on here, is at pi over 3. So that is essentially what we're doing today, is we are doing this, evaluating inverse trig functions, but I had to give you kind of that introduction so you understand those domain and range restrictions. Good luck with your lesson.